I want to use this mechanical demo as an example of how a good model can really carry a demo. In this case, actually, personally, I'm not the biggest mechanical design expert. I personally have an architectural engineering background, and I don't know all of the ins and outs of BricsCAD Mechanical. Still, I'm able to deliver a fairly decent BricsCAD Mechanical demo, even if it's just a very high-level one. And that's mainly thanks to having just a good model to work with. In this case, it's a model that was created by one of our colleagues in Russia 2 years ago. But I think it's still very relevant. It's a model of an escalator, and it allows me to show some very visually pleasing features that work really good in a high-level overview like this one. So this escalator is fully assembled in BricsCAD Mechanical, and what's more than that, it's also fully parametric. So the assembly, as you can see here on screen, consists of thousands of parts. You can also see it here in the mechanical browser. Actually, there's 3,564 parts in the assembly. It weighs almost 9 tons. But because it was created in a parametric way, we can change parameters, like for instance the height. If I want to have a floor-to-floor height of 8 meters, for instance, you will see that the model updates not only the model in the model space, but also the associated bill of material. And if there are associated drawings, they will update as well. So as you can see here, the bill of material is now updated to contain almost 5,000 parts and to weigh almost 12 tons. So again, BricsCAD Mechanical is based on, or it uses BricsCAD Pro as a platform. So all of these parts were either imported or created using direct modeling, and then 3D constraints were applied to them. Now, because this model was set up in a parametric way, it's also possible to create animations. And for this purpose, it's always interesting to show this short video of an animation. Let me start it again here. That shows basically the variations of height in this case. It can also show an animation of the actual movement of the escalator. And just showing this and explaining that it was made in BricsCAD Mechanical, which still is a DWG platform, usually amazes people, and they're usually very positively surprised by seeing these kinds of features. I'll just close this video again and go back to my model to show you some other features. And for that, I'm opening the mechanical browser where I will see the entire tree structure of my assembly. So this is a nested assembly. There's one level with another level inside it with other level inside it. So you can go as deep as you want. I'll just open this level here, this main drive shaft, to show you one of our, again, visually pleasing features. I like to show them because I just like to see it myself, which is called the exploded view feature. I'm going to create an exploded view, and I'll start off with a linear exploded view along the z-axis of this assembly. And basically, it will pull apart this assembly along this z-axis. So it's interactive with the cursor, which is also very nice, of course. But as you can see, if I choose this exploded view, if I zoom in to, let's say, this part here, you will notice not everything is exploded because these parts cannot be exploded along the z-axis because they're constrained together. That's where the automatic exploded views come in handy. So I can just start again and this time choose automatic. And it will, based on the constraints in the drawing, create an automatically exploded view for us. So this looks better already. And now I'll just place this on a sheet as well. So I will go to the Annotate tab and plot a special view. and place it on this sheet here. First, I'll change the scale. And of course, this view can also be linked with the existing bill of materials table that you can see here on the right-hand side. So every type of component in my assembly is associated with a number, and these numbers can be represented in the drawing by either clicking them one by one manually, like I did here, or by using the automatic balloon option, which makes it easy to create all the necessary balloons in the drawing. So the reason I chose this tool as well is because, again, it's visually appealing. It's nice to show these kinds of tools. And again, I'm not the biggest expert on mechanical, so I don't know too many commands, but still I'm able to show a very basic overview of what mechanical can be used for. Mainly thanks to this great model that I'm using here. All right, I think that's it from my side. I'm going to hand it back to Don.